About DBIx class, if my slides work. All right, just a second. Anyone know how I can get rid of the start menu thing down here? I run Linux and VMware, but I have to have Windows for work for some reason. I could, but it's not allowed, yeah. Okay, so I guess you'll have to just ignore that, pretend it doesn't exist. So DBIx class is an ORM. An ORM is an object relational mapper. And you're probably wondering, why do you want to map objects to relational databases? Well, let's look at this Perl code here. So here we have a little code snippet where we get a person and we say, hello person, and this is Perl 510, by the way. And if the person's age is 42, you can say that he's wise, and then we want to print out his addresses. So this is all very Perlish. It's pretty obvious what's going on here. Unfortunately, yeah, so Perl is Perlish. So in a database, though, we have stuff like this. And you know, this is a nice looking database. We have our people and our addresses, and everything's very organized. But that's not very Perlish. If we want to use that database in Perl, we have to write a lot of code. We have to write the SQL statement here. Then we have to prepare the SQL statement. Then we have to execute the SQL statement, check for errors, check for errors. Then we have to get a row. And then finally, we have some data. And it's not even in an object. It's just a bunch of values floating around. So that's not very natural. I don't like that. And plus, if you're using that in your code, you're totally coupled to your database schema. You can never go and replace that because everything's based on the SQL statements and preparing. So let's abstract this out a little bit. So now we're going to make a person class, and we have some accessors for name and addresses so we can get the data out of this object. And then to create a new one, we're just going to do this database class, prepare, execute, check for errors, fetch the data, and then we can return this little data structure. And then, so this is a blessed reference in the person class that we get the person back. We can call person name to get the name, person addresses to get the list of addresses. But we have to write all this address code, and all this does is get something from the database. It doesn't really handle updating, retrieving, or yeah, it handles retrieving, but not updating. Okay, so I think that's pretty clean code though, and at least when you get to your user code, you get person number 10, say hello, person name. So that's nice. Okay, so that's why you have an ORM. But what are the problems? Well, for every table or view or stored procedure in the database, you have to create one of these classes. And for every query that you want to do, you're going to have to create a method for that query. So you have to write all the SQL, and still your SQL is tied to one database. And that's pretty tedious. It's a lot of Perl code that you have to write, and you have to make all the SQL to generate the database and insert records into the database and all that stuff. So what's the solution? DBIx class. You can write your app instead of worrying about what the SQL looks like. So to get started with a very basic DBIx class application, we'll just use SQLite. The Perl version of SQLite uses the SQLite 3 library, so you probably have a command on your system called SQLite 3. So you run SQLite 3 database, and this will create a database called database. And then we can run our SQL to create our person table and our addresses table. Okay, and you don't have to use SQLite if you're using DBIx class. You can use MySQL, Postgres, SQL Server, Oracle, DB2, pretty much everything. If there's a database that's not supported and that DBI supports, then it'll probably work with a little bit of modification. Okay, so now let's create a package that holds our database schema. We'll call it schema in this case. And all we do is subclass DBIx class schema loader, set up some loader options. Relationships 1 tells us that we're going to load some relationships, the foreign key relationships and so on, directly from the database. And we'll also turn debug on so we can see what's going on. Okay, so then in our application code, all we need to do is say use schema, which is that package we just declared. And then my schema equals schema, oh, it shouldn't be my double colon, it should just be schema colon connect and the DSN. So in SQLite, we don't need a username and password, but of course, if you're using a different database, you can pass that. Okay, so once we've connected, we have this schema object, and now we can just get a result set that contains all people, and inside that people result set, we can look for someone that has a primary key of 1. and save that in person. And then we can say person 1 is person name, and we can store their addresses in an array. So all the nice Perl was auto-generated from the database for us. So the code's a lot cleaner. You're not coupled to database. You only had to write the create table statements, which is pretty easy to handle. So I'd say that's pretty clean. And it's totally automatic. Everything is done for you. But there is a little bit of repeating yourself, and we don't want to do that because that's a waste of time. If you want to deploy to a different database, then you're going to have to do all those create statements again and make sure you set up all the foreign keys correctly, and that's a lot of hassle. So we can manually define our schema, write our database schema in Perl once, and then we can automatically deploy that to any database engine. Okay, so let's look at how we do a schema. Basically, we just have this, we're going to call it MyApp schema now. And all our schema is, it just loads some subclasses. So we're going to have a person table and an addresses table. And you don't even have to directly specify it. If you just want to load everything in the MyApp schema namespace, you can just omit the classes, and it'll just probe for them and load all the tables or views or stored procedures or what have you. Okay, which way am I going? Okay, so each one of these classes where we did load classes, that's going to be a database object of some sort. So you can use views or tables, and if your database happens to have stored procedures that return something that looks like a table, you can abstract those out too. So pretty much anything. In the previous slides, we just did people and addresses. So let's see what the code for those look like. So this is kind of a lot of code for a slide, so I'll kind of go through this. Up at the top, we have our package declaration. It's inside MyApp schema, and it's the people object. And people is just what we're going to call this in Perl. It has no relation to what you're calling it in the database. So in the database, we called it the person table. So we say MyApp schema people, that's all this package is just an abbreviation for. And we say table is person, so we're backing this by a table called person. Then we just do a little bit of DBIx class housekeeping and set up the components. We want to do PK auto, so we get an auto incrementing primary key no matter which database engine we use. And core, you just always have to use core. There are lots of other components that you can use here, but pretty much everyone uses PK auto and core by default. So then, after that, we can set up our columns. So it's not quite as pretty as Jifty, but I mean, it gets the same point across. So we have a column called ID. Its data type is integer, can't be null, and I don't really care what size of integer it is, just pick one for me. And then we're going to have a first name and a last name, and those are varchar 50s, not null. And once the columns are defined, we're going to say that ID is our primary key, and we're going to say that our people package has many addresses. So we have an address. We're going to create an addresses accessor, which points to MyApp schema addresses, which we'll look at on the next slide. And the person in addresses is how we relate back to ourselves. And we're turning cascading delete on. There are a bunch of options that you can specify after you've set up your relation. We're going to set up cascading delete, so when you delete a person, all of their addresses go away. So that's pretty convenient. We're also going to add a unique constraint so that there are no duplicate first name, last names. I guess you could just have a compound primary key, but it's up to however you decide to design the database. Okay. Okay, so our addresses schema looks pretty much the same. If we have a chance later, I can show you the actual code, but they're just a bunch of columns. We set the primary key, and we say that each one of these addresses belongs to a person. That's the person column here. They're the same thing, and that refers back to the people schema. So once we have this schema set up, we want to test it, so we have to deploy it to a database. That we can do in about 4 lines of code. All we do is we use MyApp schema, and then we say my schema connect, and then schema deploy, and that'll deploy that schema to that database. The beta version of DBIx class does versioning for you, so it'll automatically make the necessary changes for your version upgrades. I think it's working pretty well now. And then So once we've deployed the schema, then I'm just creating a few records with the standard syntax that we'll talk about in a second. So I think that's pretty easy. It's very maintainable. You can switch from DB2 to Oracle without rewriting your application, which we're doing at work. Wasn't written in DBIx class, and we don't like DB2 anymore, so we have to rewrite our entire application, basically. If we use DBIx class, we would just flip the switch, run our unit tests, and we'd be done. Okay, so let's look at some of the things you can do with DBIx class. So the schema is the set of tables and views that we've been creating. And we get an instance of our schema by connecting. So instead of my schema new, we say my schema connect to get an instance. Looks like this. Okay, once we have our schema, we want to get result sets. In DBIx class, everything is a result set. Okay, so result sets, by default, if you just say schema result set and some table name, that's the same as select star from that table. Okay, getting ahead. Yeah, so result sets are basically a set of results. They contain records. See the DBIx class result set for everything you can do with the result set. That's where the bulk of the documentation is. So it could be hard to find, so just remember DBIx class result set is what everything in DBIx class is. Okay, so if we just do this schema result set table, if we set up that table before, that's just the same as select star from table. It's actually lazy, so it doesn't actually run the SQL until you start getting results out via accessors. So if you like iterators, this is what the code would look like. You get the table result set, and you iterate over the result set, and you get the data out of the columns via the accessors. So that's very clean. If you prefer arrays, you can use the same syntax in array context, and that will immediately fetch everything from the database into the array, and then you can iterate over it with for each if you prefer. Okay, so if you just want one record and you want to look it up by the primary key, you can just say find one, and that'll return that row. So do table find one, and then you can do with what's returned by that, you can get the first name, last name, and all that good stuff. And so that just translates to that sort of SQL. Okay, but so find will search for one record or a unique constraint. So the primary key is always a unique constraint, that's the definition. But if you set up other unique constraints like we did for first name and last name, you can use find to look up one of those. Okay, so the next thing is search. Search is where the real power comes in. So with search, we can specify any arbitrary query. So if we want to look for everyone whose name starts with John, then we have some code that looks like this. Okay, so the syntax inside all those brackets is done by the SQL abstract CPAN module. So everything that the SQL abstract module mentions is how DBIx class works. So if you want to know how to write DBIx class queries, you want to familiarize yourself with the SQL abstract manual. And there's like tons of syntax. You can do pretty much everything with pretty nice looking syntax. Okay, so let's look at some other features that we can do. One of my favorite things is I always remember having to write all this code where I wanted to get 10 records and then 10 through 20 and 20 through 30 and so on and so forth. And like, if you think about it, it's really straightforward, but it's a lot of work every time. So in DBIx class, all you have to do is get a result set, and then to get the first page of results, you just say, I want page 1. If you want the second page, you say, I want page 2. And that returns another result set, which just contains something on that page. And what's cool is you can even search within the page, because everything's a result set, and you can search and find within result sets. And so the really neat part is this pager that we can get. This pager, okay, pager is a data page object, and, okay. So pager is a data page object, and that contains pretty much everything that you want to know. It tells you what the first page is, the last page, how many entries per page, total entries, what the next page is, what the previous page was, everything you want to know. So if you want to write something at the top of your page, like this is current page of last page, showing entries on this page, entries, first through last, like this, you don't have to calculate that anymore. It's pretty easy to calculate, but you have to think about it. With this, you just say what you want to do. Okay, so now that we've selected records, we can get them all, we can get a page, we can get one, we can search. Let's create some records. So again, we have our result set, which is just the table in this case. And if we want to create a new record, we just say new, and we have a hash ref containing what we want to initialize everything to. You don't have to have that hash ref. You can just say record. You can say record key 2 is equal to value 2, and so on. And when you want to finally store that to the database, you just say insert. You can also save yourself a step and say create, and that'll immediately create the record. So you don't have to call insert afterwards. Updating works pretty much the same way. So you can get a result set by searching. You can get the first record, or you can get the first record by starting to iterate over everything. And then you just set everything in the result set to the new value. So in this case, what we're doing is if we do rs column new value, that'll set everything that matched. That'll set column to new value and everything that matched in this result set. If you just wanted to do it in the first, you would say first column equals new value. And then when you're done with everything, you just say rs update, and then everything gets pushed back to the database. Okay, so there's also a time, probably, maybe you'll get a user ID or a username. And if it doesn't exist, you want to create it. So DBIx class has a lot of ways you can do this. You can just say find or new, and if we have one, it'll return the object. If not, it'll create it in the database and return an object. We can manipulate it, and then when we're done, we just say update or create. Okay, and so the last thing is how to set up all these relationships. Full documentation is DBIx class relationship. We have pretty much everything that you want to do in there. So to just do a quick one-to-one, we just add our columns to our table A, and we can say that the thing accessor refers to the primary key of table B, so that works how you'd expect it would. We can also do many-to-many pretty easily. So if you're doing users and groups, you have a user table, a group table, and a user group table, which contains a primary key of user, primary key of group, and does the mapping that way. And so we just basically translate this to DBIx class by saying user group has a compound primary key. The user belongs to that user class. The group belongs to the group class. User has many, group has many users. User has many groups. And once we set that up, we can basically say groups equals user groups, and my list of users equals the group's users. Okay, so if there are any questions, if you have any trouble with anything in DBIx class, feel free to ask. Yes.
So you mentioned that the beta version of DBIx class has version schema upgrades. That's one of the things we've been doing for a while in Jifty. We've had to do explicit versioning. So when you make a change, you say which version a column was added in or removed in. We have only vague designs for doing it magically implicitly. What's DBIx class doing?
Basically, what we're doing is I kind of haven't really been participating in this, and I'm not sure that I completely agree with what we're doing. But basically, you need to have the code. You need to have done deploy for every version in between. Otherwise, it's not going to work. So I'm not sure that's as ideal as the Jifty syntax where you say since version, blah blah blah.
You can't upgrade across two versions.
Not without having like the upgrade definition file.
Oh.
Yeah, because
Okay.
all the upgrades are stored. They're not stored in the database. They're stored on the file system somewhere. So I'm not sure I really like that idea.
Then I'll sit here and feel smugly superior. But
It's beta.
Understood. Cool.
2.0.
Now, when is it due?
I don't know. Whenever they release it.
Cool.
I think we have a couple months or so.